Assalamualaikum and a very good day. So now we are in last week of our online lecture. We still under chapter 5, differentiation and integration, but now we'll cover this integration. So for today, we'll go to the basic of integration. I will give you some overview of the integration techniques. Then we'll go to application of integration, which cover area and volume. First, we go to the basic of integration. Actually, integration is a reverse of the differentiation. For example, here we have learned before this A is given by delta D, which is this D is distance, which is this one is rate of change in distance with respect to the time. So if we know, for example, speed changes. For example, we know the speed changes and now we want to find distance. How we can do that means that now we need to undo finding the rate of change with respect to time. Undo finding here means that we need to reverse differentiate function. Differentiating backward is used to find actually the area under the function. So now if let's say we have this graph, if you differentiate function, you will got, for example, this rate of change. But now we want to do reverse. When we do reverse, in this case, we'll find here the area under this curve, which is starting from this limit up to this end of limit. So integration means that it is estimating area under the curve. To estimate area under a function, we can split the area into vertical strips. So what does it mean here? Let's say we have, for example, this kind of curve. This one is given by fx. So we want to find the area under this curve. That is, we do reverse differentiation, means that we find this area. But in this case, first, we can split this area into vertical strips. So now we have some vertical strips here, which is, it can be formed in terms of trapezoid. So we have this one, and this one. And then this distance is given by delta x, means that the rate of change in x. And this one is given by fx, because you know this point will give you a value of fx, this one also fx, this one also fx at certain point. When we want to compute this one, how can we find? When we want to find the first integration here, that is the first area here. For the first part, this one, the area equal to fx times delta x. And then, if we have many strips here, means that we need to take sum. This I1 plus I2 plus I3 plus I4 plus I5 means that we need to take sum for all this. So here, our area or the total area is given by the sum of fx times delta x, which is given by this formula. As the strips get narrow, means that here when our delta x approaching 0, so when this delta x becomes smaller and smaller, we can have here many strips. Okay, so in this case, the area of this function can be written as same formula, but now our delta x, which is here, it is approaching 0. So that, based on the previous concept, the algebraic method for finding area under a function, we call it as integration. Integration uses a reverse differentiation, means that to undo finding the rate of change. So area under the function fx, as we know, is given by this sum fx delta x, as delta x tend to 0 can be denoted by integration of fx dx. And here, this fx can be any function. We need to understand differentiating backwards. Here we have integration involve differentiating in reverse. For example, from fx, if we want to get f prime x, we need to multiply by the power and then we reduce the power by 1. However, from this f prime x, to get back its fx, we need to increase the power by 1 and then we need to divide by the power. What does it mean here? For example, if I have dy dx, which is equal to f prime x equal to x to the power of 3. In this case, when I integrate this both sides, so that I will integrate dy equal to integration of x to the power of 3 dx. In this case, we need to increase the power of this x by 1. So here I have x to the power of 4. And then we need to divide by the power. Means that we divide by 4. So we have here x to the power of 4 over 4 as the solution for this y. So now when we integrate this side, it's become. Now we want to know about finding the antiderivative. What does it mean by antiderivative? Here the result of differentiation is co-derivative. Means that when you differentiate function, you get the solution, we call it as derivative. However, when we do backward, that is the result of differentiating backwards, we call it as antiderivative. If I ask the question to find the antiderivative of y, means that it is same. I ask you to integrate function. If let's say we have this example, means that finding finding the integration of this dy dx or antiderivative of y, you have to integrate both sides, which is integrate dy equal to integrate ax power 3 plus x squared minus 6x dx. In this case, we can expand this one. So we got here integrate ax to the power of 3 dx plus integrate x squared dx minus integrate 6x dx. When we solve this one, we'll got here ax to the power of 4 divided by 4 plus x to the power of 3 divided by 3 minus 6x squared divided by 2. When we simplify here, we'll got the answer equal to 2x to the power of 4 plus 1 over 3x to the power of 3 minus 3x. Now we go to the constant of the integration. When we differentiate function, part of expression is often lost. What does it mean here? Let's say we go to this example. We have fx equal to x to the power of 4. We have the second fx, which is x to the power of 4 plus 2. And we have the third fx, which is x to the power of 4 minus 7. When I compute f prime x for each fx here, I will got for the first one, f prime x equal to 4x to the power of 3. For the second one, I will have f prime x equal to 4x to the power of 3 plus 0. And then for the third one, f prime x equal to 4x to the power of 3 minus 0. As we can see here, for all fx here, we have the same solution, that is 4x to the power of 3. But the antiderivative of f prime x cannot just based on this x to the power of 4, because you can see you have different solution here. So now, if I want to take antiderivative for this one, so I have here dy dx equal to 4x to the power of 3. Antiderivative means that we find y, we integrate both sides here. So integration of dy equal to integration 4x to the power of 3 dx. When we solve this one, we got this y equal to 4x to the power of 4 divided by 4. But we cannot just leave our answer here. We need to plus with c, which is this c is unknown constant. Means that we'll got this one, x to the power of 4 plus c. So this c can be any unknown constant. It can be 0, it can be 2, it can be negative 7. Means that here, for this part, we call it constant of integration. Now we go to the next part, which is the result of integration is usually called an integral. What does it mean by this one? When we integrate function, our final result here we call it as integral. So for example, we have fx equal to x to the power of 6. And the question asks us to integrate this fx, means that we'll got integration x to the power of 6 dx. So this is our final answer, because this part we got x to the power of 7 over 7, and we need to plus with c. And for this one, find the integral of 4 over the square root of x dx. So in this case, we have integration of 4x to the power of negative 1 over 2 dx. When we solve this one, we got 4x negative 1 over 2 plus 1 divided by negative 1 over 2 plus 1 plus c. When we solve this part and this one, we got 4x to the power of 1 over 2 over 1 over 2 plus c. Simplification of this, you will got this ax to the power of half plus c, which is this one, we can write as a square root of. Now we go to how we can evaluate definite integral. What does it mean by definite integral? Definite integral means that you have a limit of x1 and x2, and here can be any function. So when we want to integrate, when the limit is given, our constant c, we can find its value. For example, in this case, we want to integrate from 0 to 3 to x to the power of 3 dx. When you integrate this one, you will got, for this part, we have 2x to the power of 4 over 4 plus c. Simplification of this part, you will got 1 over 2x to the power of 4 plus c. But now we cannot just remain our answer like this. We have to substitute with 0 and 3 for x. When we substitute for 0 and 3 for x, you can see here, for the first part, we have x equal to 3, so we have this term. And then c still here, minus 1 over 2 times 0 to the power of 4 plus c. So when we solve this one, c minus c, we cancel out. Now we got our definite integral, that is, we have a value for our integration. So class, we have learned some basic of integration. In the next video, we will learn how to compute area using integration. Thank you.